Okay, well, here we are. We are live on Amazon, and I'm going to be talking with Noelle Russell today about her book that's coming out, Scaling Responsible AI from Enthusiasm to Execution. You can see it right there. There's the author, there is the book, and it is clickable right in the carousel. So let's put that away for a moment. Uh, Noelle, I'm excited to talk to you because
Okay.
AI is like the big thing, but in some ways, I think of it like chlorophyll in the 50s, right? Where it was like everything. Maybe in the 80s, it was frozen yogurt bars, right? Everyone had a frozen yogurt bar. It was just like Tony's small engine repair and frozen yogurt bar,
Yeah, exactly.
right? And now it's like
Absolutely.
everything with AI, right?
Absolutely.
It's like maybe it was in the 70s, 60s when it was on TV and it was in color. And then in the 2000s, it was in HD,
Yeah,
broadcast in HD,
that,
right? Now you got to have AI. So, welcome to the program. I'm glad to have you here.
thank you. I'm excited to be here. It'll be a fun conversation.
Oh, we're gonna have a great time, and I'm just gonna throw a few things into the carousel that I like that I use. Which I have my Zoom
Cool.
Q8N 4K. This little
Okay.
camera. It's got the built-in microphones, but I've got the XLRs. This is my mobile studio when I go out, and I actually use a pair of Shure SM7Bs when we're out doing the recording here at home. I've got my Electro Voice RE20, which is
Which
like,
does sound amazing.
it sounds great. It looks cool. All of my editing is done through these AKG K240 headphones, reference headphones. What else have I got? A joint book I did freeze.
Oh,
So
cool.
we're going to be talking today with you, Noelle, about AI and really on a large scale, right? And we're going to talk about the big scale. This is for small business. Uh, Networking for students. This is my book. Buy this for the student in your life who wants to have an unfair advantage. Uh, Business networking, connecting, internships, job applications, school applications, getting promotions for the jobs they have, networking, a skill they'll use for the rest of their lives. And then finally, my independent planner. This
What?
is the 4-month planner. The key here is that there's this goal tracker. So not only I actually have a GPT, by the way, programmed to help people. So if you go to the independent-planner.com, don't do that, but go there. You can use the AI powered tool to set a 3-year vision for your life in 6 areas. And then it'll help you create goals to meet it. And then it'll create an ideal week that you can live by. And then you can track it all right here in the independent planner, available on Amazon. So I
So
think
many of
those are
us
the highlights
like,
of the things that I'm
like
using.
the combination of like GPTs and the physical form. I mean, I'm like that person. Like I have a physical book, even though I have all this technology around me. It's so good when you can complement the two together. So that's awesome.
Yeah, that was the deal was that a number of years ago, my digital calendar by a provider not named that starts with G let me down.
Yeah.
Right? My phone rings and it's like, "Hey, Scott, this is Noelle. I thought we were getting together on Amazon."
Yeah.
And digital calendar let me down. I can't afford that.
Yeah.
So, having used Franklin planners for 20 years and all the different versions of time systems and day runner and using blank journals and writing them out myself, none of them actually tracked my goals. And this leverages brain science. So you fill out your calendar for the day, you look at the things that are linked to goals, you put them in the goal tracker, which is great to put them there, but you don't get to color in the segments unless you actually do it.
Yep.
So if it says, I'm going to write my AI book for 2 hours a day, it's
Right.
great to put it on the calendar, but if you don't sit down and do it, you don't get to color it in.
Yeah.
When you color it in, the dopamine fires off
That's
and
right.
the world is better because we've got this right here. This is how it ends up, right?
Yeah, exactly.
Scaling responsible AI. So you were on the Alexa team early on. You've been in IBM. been with Microsoft. Let's kind of start to go through and tell us about your background and what brought you into this world of AI.
Absolutely. Yeah. I actually have always been very interested in, I guess, what we would call emerging technologies. So my career, I always was kind of chasing the newest thing back in, the Y2K timeframe. I was teaching kind of old dogs, new tricks in the terms of, a lot of old mainframe programmers needed to learn client server. And I was right there, like doing what I do now for AI, I was doing for people learning how to build applications in the world of functional programming. But from there, I ended up, just following the technology, always kind of searching for that next cool new thing. I was at VMware when virtualization was becoming a thing. This is before AWS and Microsoft all started working in the cloud. But it led me to AWS because I was at VMware. I became very interesting to AWS, who was just starting their cloud kind of takeover. And so
Right.
I became a cloud architect. And again, eventually, I was there maybe a year, and I got an opportunity. Jeff Bezos ended up sending an email out to the company inviting people to join a brand new team, the Amazon Alexa team. And granted, I had no experience in artificial intelligence, no experience in, natural language understanding or speech recognition, none of this stuff. But I had a very keen interest in tech I could talk to, like the Star Trek computer. I was very interested in that.
Yes. Yes.
And so I ended up, this was 10 years ago now, a little over 10 years ago, being one of the earliest members, employee like 10 on the skills team. And it was a crazy time because we actually couldn't, we were trying to get people to join this team. And back then, nobody really cared that much about AI. And they didn't see it as an opportunity to grow their career. They actually thought it was pretty risky back then. But I'm all about risk. So I jumped at the opportunity. And of course, that led me, I mean, I was there 4 years, built Amazon Alexa from nothing to about 500 million homes, and then got recruited by Microsoft and got a chance to go there and help deploy AI for everyone, which was a bunch of these AI models that we gave to developers. But again, this is like 2018, so the world wasn't quite ready. It was like feeding vegetables to kids.
Right.
So I was like, take this AI, you'll love it, I promise, it's good for you. But not a lot of people were taking advantage. And then, of course, ChatGPT was born and everyone started paying attention. Everyone started using it. I'm like, oh, you're finally listening. And so,
Well, that was the key, right? Was when ChatGPT came available. It was a little over 2 years ago, right?
yeah.
And it was, I always say it was AI for mortals like me, right? We
Yeah.
got to play around with it. But this is the issue you're talking about, is on scalability, right? And in the coaching, consulting, the work that you've done independently that led up to this book was talk about scaling and how do you scale this, and just to give people an understanding of what this looks like. So I'm here in Texas, but recently came from Oregon, from the Northwest. And in the Northwest, it's all about craft beer, right? And so you got people out in their garage making bottles of beer, and they're pull them in, put the cap on, and set it aside, right? Then they do pretty good, and they decide to scale it up. And so now they've got machines, and they're doing some automatic filling and capping and doing it, and they're sending out pallets, boxes a day, right? Restaurants, bars, whatever. Craft beer. So then my wife and I are watching this program on the BBC, and it's talking about making cider, and they manufacture this place 7/24 it operates, right? Because they make 1 million bottles a day. Okay. So when the guy's in his garage and he's bottling it, right? Every one, he looks at it, puts the label on it.
Yeah.
And even when you're sending them out by a truckload at a time, you can pretty much inspect every one of these things. When you're bottling 1 million bottles a day, the bottles are a blur, a literal blur as they're going by, right? Your eyes cannot focus on them. They're filling, capping, boxing so fast. There's no way you can see. a fraction of those, right?
Exactly.
So on the GPT that I created, as we were talking about this earlier, I can basically get 100%. I can look at 100% of those results that I work with, right? If people are using it to help them write emails or newsletters or their marketing things, they're putting in the input and they're looking at it 100%. But what you're talking about is a million bottles a day flying by at a blur.
Yeah.
So let's talk about what it really means to scale AI.
Absolutely. And it's so interesting because I love this idea. I I remember the days of, I don't know if you remember these Groupon coupons we would make
Oh
and
my gosh, right?
right? And how it would either be the best day of your life from a business perspective or the worst day, or sometimes be the best day and then end up your worst day. And it literally was a function of exactly what you're talking about, of this scaling. And what people often don't realize with artificial intelligence, especially with devices like Alexa or Siri or Google Assistant, that when you put your brand and you add AI to your brand, you're now increasing the surface at which people can communicate to you. So, which is great. Like Groupon coupon, let's go. Like that's what we want. We want to 10x, 100x, 1000x our customers. In our mind, it sounds like a great idea. But at the same time, when you get that much influx and you don't have the ability to see everything, you can't watch every interaction, you can't watch every bottle of beer that goes out the door, it becomes critical that you implement certain processes that you can trust to do some of that work for you. And some of it's not AI at all. Some of it literally is just good old fashioned automation that's going to make sure everyone who got a bottle of beer, everyone had a label on it. Right.
Mhm.
And that doesn't have to be an AI generated thing. It's just to ensure like you're going to have a machine that slaps a label on every single bottle regardless. But there is, when we move into the world of AI, now we're not just talking about kind of a mechanic or a mechanism. It's actually human language. So it massively expands what we have to be worried about and consider, because you now have to consider everything a human might say to your system, everything a human might ask it to do. And typically, the way we create really strong, successful AI systems, the very first thing we do, similar to with your GPT, is that you figure out what's a problem I want to solve. Like we scope it immediately, right? For those of us in business and consulting, like we understand problem definition. Like we have to figure out, what do we want our AI system to do and how are we going to measure its success? And that is often not the first step companies take. Most companies, they just go and dive right in and grab a model and start using it. And they don't even really think about this. But that problem determination is a critical kind of linchpin moment for most organizations on whether they're going to be successful or unsuccessful in generating business value with this stuff. But that scale is, yeah, it can come up and surprise you.
Right. So I'm going to put this back up. So today, here on Amazon Live, talking with Noelle Russell, Scaling Responsible AI. This is her book. It's coming out. I would go ahead and buy this now for yourself to be an informed consumer. You have already been surrounded by AI. If you've used a word processing program that corrects your grammar, you're involved in AI. If you've done a search on a digital search engine on the web, you have been surrounded by AI. And Trey says hello. So he's watching on Amazon. So Trey, good to have you here.
Awesome.
Yeah. So Noelle, this we have seen the embarrassments to big companies. So what went wrong?
Yes, AI gone wrong. Oftentimes I call them baby tiger moments. And I, what I mean by that, you'll actually notice, right, there's a tiger on the cover of my book, and that's not an accident. I have a very specific kind of analogy that I use to represent the world we're in right now. And it's literally right now, every company is kind of doing what you were mentioning. We're all building, we're making our own craft beer, whether it's human resources or user experience or product management or building a company that's serving other people with products or services. We're doing it at a pretty small scale. Typically, every project, even the big ones, start very small. However, and in that smallness, I actually have baby tigers all over the place. I always say, like, when you get a little model, it's like a baby tiger, because especially large language models like ChatGPT, they're very cute. Like, these models are very entertaining. They give you pretty good answers. You're like, well, that's not terrible. I like this. But no one in the first, like in that early baby tiger mode, no one's asking things like, wow, big paws, like how big are you going to be? Or razor sharp teeth at birth. What do you eat? How much do you eat? Where are you going to live? What's going to happen when I don't want you anymore? No one asks those questions on the first day. They only often answer those like Groupon on the day that bad things begin to happen. And some of those are very easy. I mean, it seems very nuanced, but like, let's say I build a customer service agent for my website. So many of us did that over the last 10 years, build a customer service agent. But let's say we now build it with today's AI. Today's AI not just will answer the questions that we ask it to answer, it could answer potentially any question about anything unless you tell it not to. So in 10 years ago, when we built AI systems, we gave it an allow list. Here's what you're allowed to do. Anything outside of that, you're not allowed to do. Today, it's the opposite. If you don't give it any guardrails, it's allowed to do anything, which means you not only have to tell it what to do, you also have to tell it what not to do. And that is a step many organizations often miss. We had an airline recently launch a customer service agent. Very nice. Their core values in the company was like, customers always right. Well, those customers started coming to this chatbot saying, I deserve a refund, even if the refund was not in alignment with refund policies. But the AI bot was taught, hey, the customer's always right. And it reasoned, it thought to itself as a machine, let me think about this. You know what? I actually do think you deserve a refund. This is the AI system. And it's like, I think I'll manufacture a new refund policy because I believe you, sir. I think you should get a refund. And it started manufacturing and generating new refund policies. Now, if you're the business owner and you have an employee who's just giving money away because they think the person's nice and deserves it, you might want to fire them. With AI, it's much harder. An AI system
gosh.
embedded in your architecture.
You know, so I was just talking to a customer that he's working with the whole Google review thing.
Yes.
And he's new to this, right? And reviews are very important, especially in a customer-facing business. In a restaurant. That's a restaurant. I mean, I'm going to decide if I'm new in the community or traveling through, I'm looking for that one that's got a lot of reviews. It's 4+ stars. And so we were talking about those negative reviews. And you say, don't not acknowledge them because that's a bad idea.
Right.
But don't create an online public discussion and do things like, well, why don't you, I apologize. Come on down for a free appetizer, right? Because that's going to incent people to go, oh, I'm going to give them a bad review.
It's crazy.
So the AI is could be creating a bad snowball, a yellow snowball.
100%. Yeah, a vicious cycle. And that's why I think it's really interesting because we don't think about it when we build these systems because we're in this like baby tiger mode. We're very like just enamored with the fact that the AI system can do something. And we literally we don't need to know technology. We don't need to be an engineer. We don't need to be a data scientist. We don't even need to have graduated from high school. All we need to know is how to say something to a machine. And that, I mean, granted, you say it, it's going to give you a plausible response back, which is also dangerous because now we begin to over rely on the fact that it seems plausible. There was a lawyer recently in the last year who ended up asking this AI system to help it with its case briefing. Turns out that model, in its effort to please the user, manufactured and made up entire cases to support that case briefing. And the model, though, and in the model's defense and in the data scientist's defense, the model said, by the way, you should check this, as ChatGPT does every time. Right at the bottom, it's like, check your answers. I could be wrong about this. But the guy's like, it looks pretty good to me. That guy ended up submitting that case brief, getting just smacked down by the judge, ended up in contempt of court, like bad news.
Just everything gone, right? And this is I want to talk about these models that are out there because we're familiar with these large language models, right? Well, familiar. It's the one that where you get to play with, right? This ChatGPT. It's a particular thing. In the lawyer's case, this was The problem was the data set that was being fed in, right? So if LexisNexis, which is the law library, if that was the database and it was pulling from that, then
Exclusively.
it could be then, not creating, because it can only use
That's
this material, right?
that's right.
And
Yeah,
so
this
this
is
is
all,
this is the problem. So let's talk about that.
absolutely. So this, and it's actually great because I was just talking to an audience, and one of the people in the audience had asked some questions. I always love Q&A section of my sessions that I do. And one of the questions was like, so what do you think? Do you think this AI is getting smarter? Do you think it's getting better at answering questions? And I thought it was interesting, the framing of that question, this AI, as if there's
Mm.
like a big AI in the sky, right? Like one single AI that we're all talking to, and that it's getting holistically smarter. And so one of the things I can encourage you all to just investigate for yourself is there are millions of AI models, millions of them. And many of them are purpose built to solve a very specific problem. Hence, that initial instruction, right? Like the first thing we do is figure out the problem so that we can identify the right model, the right AI system to solve it. For example, ChatGPT is good at general reasoning, but Claude was built specifically from a marketing team. So it's very good at direct response marketing, copywriting, and those types of tasks. Most people don't know that. They just think one's written by one company, one's written by another company, like they're all kind of the same. They're really not the same. And so I think it's important for the world to know that you can actually build your own model. You can take what's called an open source model and create your own. You can train it, as you just mentioned, on your own data. Enter complex implementations like the government, the federal government, or state and local government, or finance, healthcare. We can't have these models manufacturing diagnoses or treatment plans from the internet. Like, that's not going to be okay. So instead, for example, at Microsoft, they created a healthcare like governance cloud, and that cloud does exactly what you said with LexisNexis data, but with healthcare data, that they identify what's under HIPAA compliance. Like what are the regulatory standards? What's the data sets we're going to use? And all those data sets are owned by different companies, and they all get their chunk of the pie. But we own it. We ring fence it is a term we use in technology. We put kind of a rail around it so that the model can't just go to the internet and find something and make up an answer. Now, I want to remind you all that generative AI, or what we're talking about here, AI in general, is often called like ChatGPT. GPT is an acronym, right? It basically stands for generative, which you probably all can relate to, right? Creating stuff. That's its main job. It's kind of like ingredients on the back of a chocolate chip muffin like bag that you make. Maybe none of y'all make chocolate chip muffins out of a bag, but I do. I've got 6 kids, so I got to do things. But I have that recipe, and the first ingredient is always the one that is kind of the most important or has the most of it. So generative AI is similar. Its job is to create answers for you. But the second letter, P, is where all of the bad things happen. It's pre-trained. And what that means is that it's pre-trained on the internet's data. And you don't want to use any of that, because I don't know if you know, in 2021, when a generative model asked the internet who was president, even though there was a sitting president at the time, it could not answer that question clearly. Even today, some of these models get confused. And the reason they get confused is because there's conflicting data, right? There's data on the internet. Some blogger somewhere wrote, this isn't the president who's president, isn't the president. It's this other guy over here that I like. No matter who it is, there's some crazy people blogging their opinions. That's the beauty of the internet. But when you ask it to serve truth, right? When you ask it to actually tell you something real, the only way to do that is to own it yourself. And for those of you scholars out there who want to do some homework, it's an architecture known as retrieval augmented generation, which means we're augmenting the model's tendency to go to the internet to find an answer. We're turning its eyes, putting on blinders, and augmenting that generation to a very specific data set. And that's when all the fun happens, because now our models stop lying and they start telling the truth. But fun fact, most people's data sets also has conflicting data. So the model still hallucinates, but not on the internet, on their own organizational data. And that's pretty fun to expose to people sometimes. Like, yeah, you have 2 documents that say the exact opposite thing in your company. You should probably fix that.
Yeah, it was, this is not AI, but it was pulling from a data set. Way back, early on in my career, I was working for a bank, and I'm in the back room and I find these printouts, right? So it's the fan fold, green and white bar, wide carriage, pin fed paper. And it was just uh, hundreds of pounds of these things in the back. And I found it contained all the transactions that were run through for that branch. So I'm operations manager. Part of my responsibility is scheduling. So I had so many uh, human hours to apply over the course of the time that we're open, right? So I looked at this and I said, well, and this is the question I ask. I go, could I predict my transaction volume if I look at the date of the month, right? Because people get paid on the 1st and the 15th, and Social Security checks are paid on the 3rd, and right? And then the day of the week. Monday is better, is busier than Tuesday, and so forth, right? So I numbered 1 through 5 for the 5 work days of the week. I put them into let's see, it was Lotus 123
My goodness.
was the spreadsheet we used, right?
I was 12 years at IBM. I know it very well.
Yeah. So Lotus 123 was, and by the way, the bank that we worked at, this was the days when we had one PC in the branch. Everything else was dumb terminals connected to a mainframe. And so I'm over there and nobody knew how to turn this thing on, right? So I turn it on. Oh, it's got Lotus 123. And I said, what if we did this? So then I sorted the data, right? And so then I could go, oh, so today is Monday the 10th. And then I would sort for that and look over at the transactions, and I would have so many Monday the 10ths. And I could look at the transaction volume, and then I applied a standard time, 2.5 minutes per transaction. So I knew how many staffing hours I needed for that day, right?
Yep. Pattern matching.
And it worked, right? Because I fed it a certain amount of data, was looking for a particular result, and then I was plus or minus 3%, by the way, on that. And so that this is not AI, but I was taking basically 3 pieces of data: date of the month, day of the week, and transaction volume.
Yeah.
Now the problem,
AI, I mean, you're the human in the loop, so to speak, but you are creating an algorithm, right? And you're doing what's called feature engineering, which is a concept in machine learning where you take certain features. There's lots of data in that transaction, right? But you're taking 3 specific pieces of data and asking yourself how you can correlate those together. I mean, the benefit of a machine is that you can teach it that pattern and ask it to go look for that, as opposed to you had to do.
And this is where it comes into the computing power that we have today, right? That says, okay, I want to look at 1 million variables, right? I want to look at what was the temperature yesterday, the temperature tomorrow, what's the forecast, what was the stock market? I'm going to feed all these things in to tell me how many transactions I should run, how many staffing hours I should run for that day. But I can't feed that many data points in or even correlate it. But this is where a tool could say, well, here, I don't even know what all the variables are.
Right.
But it could start looking at these and doing some historical look about. And some of this, I guess one of the questions is, what's the difference between machine learning and AI?
Oh, goodness. That's a great question. I also had this question a couple of days ago. And it's interesting because it's I consider them a bit of a subset, right? AI has become this very generalized term, like overarching, huge umbrella. The umbrella used to be this big. Now it's like there's some insurance company that has an umbrella this big, like
yes, right.
Umbrella, right? And that umbrella now contains a bunch of different AI types of AI. Machine learning is one type of AI where you build basically these algorithms. You create a statistical algorithm to do exactly what you're doing, identify patterns in data sets. And there's there's hundreds, maybe thousands of different ways, and people are inventing them all the time in academia, different ways of finding these patterns. Some patterns are regression patterns. Some patterns are similarity patterns, clustering patterns, right? And so similar to what you're saying, like with machine learning, what I can do is say, hey, machine, here's a bunch of data, and I'm going to label that data. I'm going to go in and tell the machine, this is what a dog looks like. This is what a cat looks like. This is what a house looks like. Like I'm literally, the machine's not like coming up with this on its own. It's called machine learning because we have to teach it. So as humans, we train it, and there's a bunch of different types of machine learning. But this specifically is like supervised learning, which means I, as the teacher, I'm going to tell you what is true. This is a cat. This is a dog. This is a house. I'm going to give you that. Then I'm going to give you a different set of data as testing data. So I'm going to pass in some pictures of houses and be like, okay, I told you what a house looks like. Can you tell? Yes or no? But it's not yes or no. It's actually degrees of confidence. It's called a confidence interval, or this concept of a percentage. So it's going to say, okay, on a scale of 1 to 100, here's how confident I am that I think it's a house. And it might be 60% confident, which is slightly better than a coin toss, or it might be 98% confident. And lots of different things come into effect, right? Does it have a triangle in its frame? Is it colored the certain color? But that training process, machine learning, means we are taking the time to give it data and teach it what good looks like, what a good decision is. That's why it's learning. It's not machine teaching. It's not machine osmosis. It's machine learning because we're teaching it as humans how to make good decisions. Now that is applied all over the place. That is not LLMs. That's not ChatGPT. Right? ChatGPT is a specialized version of machine learning, which is all the way down, like lots and lots. I mean, there's supervised, unsupervised, reinforcement learning, CNNs, RNNs, and all the way at the end is a large language model, of which one type is called a transformer. And that just lets us close the loop on GPT, right? Generative, pre-trained, and that last T, it stands for transformer, which is a specific type of machine learning model. So that's, I think, important for everyone to know, again, in that spirit of this is not one big AI in the sky. These are all different machine learning techniques that have been used to solve very specific problems. And that's why sometimes models are good at passing the bar, and other models can't add 1 + 1 in a financial model.
Right.
Because they're trained to do different things. And it's really important that we understand the problem first, so we pick the right model for the right task.
So let me put this back up. I just want people right now, just click add to cart. Go down to the and click add to cart, buy the book, Scaling Responsible AI from Enthusiasm to Execution. And we're just having a great time with Noelle today. I'm learning a lot, and I trust that everyone else is learning and being inspired and not being afraid, because we're afraid of things that we don't understand, right? I mean, that's what makes horror movies, right? Because we don't understand and we get afraid. So we don't need to be afraid if we take time to understand. And so one of the first public demonstrations that I'm aware of AI was Watson playing Jeopardy.
Oh, yes.
Right. And so I remember that. And at the time I was running a specialty agricultural company. We focused on soil microbiology. And so we would actually measure the biomass of bacteria and fungi and protozoa for every gram of soil, right? And to do that, it was a very labor-intensive process. You would prepare the slide, they'd put dye on it, the lab tech would look at it under the microscope, and then with certain wavelengths of light, this fungi would glow green, and there's a grid on there, and they'd measure it and count. And I remember back watching this Watson thing and understanding how it was trained, and I'll ask you about that in a moment. But I said, could we take slides and point out, count this, count that, count this? And, we had like 20,000 samples in the database. So I'm going, we could probably teach this thing, and we could instead of having the lab, this lab tech then prepares the slide.
Yes.
We put it in, it captures a digital image, it feeds it in, does all the measurement calculation. I said, we can check this, but let's talk about this public demonstration, Jeopardy, being Watson won, I believe, in that
Did.
one. Go ahead, tell us about that.
Yeah, really fun. I love this example. One, half my career at the time was at IBM, so I was a big fan of like all the things that were happening there. And Watson, I mean, lots of good companies. Watson, Google, all create. I mean, Google was the one that patented the transformer. Like they were the one who came up with the transformer. But when you get to be so big, you could do some of these cool things, but oftentimes it's really hard to innovate even in your own organization where you've got these amazing ideas. And so a small company called OpenAI, just, half a dozen people, similar to other AI companies that became big companies, but they started really small. They took the transformer from Google and kaboom, built this massive competitive product. It's just crazy to me. And Watson had the same fate, sadly, like such good tech. IBM owns the most AI patents in the world, like 3,800 or something, like owns all, like the most. And they are not the first in the market, which breaks my heart. But this was big for them, this moment, right? Building Big Blue. And so just to give you, and of course I was not on that team, but to give you kind of anecdotally, the process that's used to train a model like that, it's very similar to what you're talking about. The first step is just analyzing what have humans done in the past. So that's the first thing, is collecting as much data as we can about how humans think through either, right? I was thinking about me and my like pool and my sauna, like my hot tub where I have to take the little dipstick thing and check the
Right.
colors and the pH. And I was like, that's what I felt like you were talking. I was like, I know that. And how imprecise it is. Because I'm just looking at it going, I think that's teal. It looks kind of teal to me.
Right. Yeah. And has your reference faded at all or not?
Yeah, exactly. How long have I waited? Like all of these things. Like, did I have a cough and I like come back and now it's a different color? Like all of these things that increase the ineffectiveness of the process that with math become very precise, right? So these numbers can be addressed immediately. So that's what ended up happening. They went and grabbed all of the, anyone who was a grandmaster that had successfully completed and attained the grandmaster title. They took all of their books. And here's the fun thing about chess grandmasters, they do like to teach people. So they've documented many of their strategies in books and resources. And so they took all of this information and gave it to the machine in the same way I told the machine, here's what a dog looks like. Here's what a cat looks like. They said, here's what a castle looks like. Here's what, a pawn strategy looks like. Here's what here's all the different pieces, all the different moves. And most importantly, here's what failure looks like. Here's how to lose a game. And here's how to win a game. And the challenge is that when you are a human, there's only so many, even if you're a grandmaster and have hundreds of thousands of combinations in your mind that you can use at your disposal at any time, it's very hard to compete with a machine that can hold millions of those in its proverbial mind at any given time. Millions. And that's why it becomes so interesting. And machines have lost to humans, but often the linchpin to that moment that the computer lost was when the person who was playing the computer did something unpredictable, which means that now we as humans, and this is something I said at CES this year, I mean, the value we have as humans, and I think it was at a creative event where it was all like movie and musicians and authors. And I was like, the art in the creativity that we have is our ability to go off script at any time. The reality is that these machines, though, as off script as we might think they are, because we don't know how they were trained to do everything that they do. They got that training from some data set somewhere. An algorithm derived that truth from something we taught it. And all machines start that way. So if we are able to go off script, if we're able to deviate from tradition, from the norm, that is where we can actually see, a machine losing in that case. But otherwise, we can train it on every grandmaster and it can have that in random access memory in its brain to play any specific play. So it's literally able to look at the board and see 15 ways to checkmate when we as a human might only see 3.
Well, and this was, they actually did a study on this years ago where they studied grandmasters, right?
Yes.
And they said, the conventional wisdom was this grandmaster looks at the board and goes, well, if I do this and you do that and then this and that and that, and no, but if I do this and then,
Yeah.
well, that's an infinite number of combinations, practically speaking, right?
Yes.
And even a computer can't do that
Yep.
realistically, right? But it turned out that the grandmasters, the reason they could go into that gymnasium with 30 chessboards and go from board to board to board to board, so look at it, move and move forward and win the majority of those games, is because they learn by pattern.
Yes.
So they look at it and they go, oh, and because they've got this huge database of playing games, this is what's happening. Therefore, this is what I do. I sacrifice this pawn. I advance the knight or whatever it is, right?
Yes.
And so I was just thinking, Gene Roddenberry understood this whole thing about being unpredictable, right? That was the whole Captain Kirk and Mr. Spock logic versus chess versus poker, right? We saw this in the 60s with Roddenberry, right? So yeah, that I love what you're talking about there. So the way to break the AI is to be unpredictable.
Yes.
But this brings up another question, because the AI literally of March 9th is not the AI of the 10th of March.
Right.
And tomorrow is going to be way different.
Yes.
And so what was it, Moore's law with the doubling of technology and so forth? I think it's much faster in the AI world.
100%. I mean, we've seen this already, right? To go from a world that would not really talk to Alexa or Siri very often to now have, a billion people, billions of utterances being said, comments, words, text strings being passed into ChatGPT every day, like every day. It is incredible what happened in just 6 months of that product's launch, let alone 2 years, where I now, when I go in front of people, I could be in a room with 2,000 people. And if I ask them, how many of you have used a model like ChatGPT, 90% of the rooms, hands go up. And even on the best day during Amazon Alexa, when we had a pretty good market share, like there were 4 years before Google even launched their product. So if you wanted to talk to your tech, that was the only game in town.
Well,
and even
I have to throw this audio meme in about Alexa when they said, why did Amazon buy the Whole Foods grocery store? Is because Jeff Bezos said to Alexa, right? We need to buy more Whole Foods. Buying Whole Foods.
Exactly.
Anyway, that was
carrots,
audio meme.
Beets. Yeah. I remember that. That was really funny when that came out. It was like Alexa humor.
We all love that stuff. There we go. We got our little our thumbs up.
That's
Let me just put this on the screen.
Thank you. Amazing.
All right, Noelle Russell, scaling responsible AI. We're going to talk about the responsible part here in a moment. And I don't have this book in the carousel, but I am going to put a plug in for my friend Matt Rouse in his book, Will AI Take My Job? And I'm not going to divulge anything on that. Will AI take my job? If you're lucky. If you're lucky,
You're 100% right. I always say it's not a job killer, it's a task killer. And I haven't met a single person that was sad that the task I choreographed away from their work every day. No one is sad when that happens. The challenge, I think, is that we don't take the time to examine what we do. That's why I love the way we started with your journal, right? Like when you actually have a goal and then you reverse engineer how to get to that goal, now your time, the minutes you have in every day become critical to your ability to deliver those results of that goal that you want. So do you want to waste your day building PowerPoint presentations or scanning through email or finding a PowerPoint, or spreadsheet on your laptop? Like every minute counts right now. And I have a bunch of kids. So I not only am I trying to make my dreams and my goals come true, I also want to be a good parent and a good spouse and a good caregiver to my dad. So every minute counts. So in that world, if you're lucky, it'll take these tasks from you that are eating your life away. And not only that, those tasks, not only do they steal your time, they almost always steal your joy. It's frustrating to do. We don't like doing them. It makes us, 78% of people who currently have a role in a company are not excited to be there, are not motivated to be there. And 19% of people who have jobs are actively sabotaging the company they work for. Actively sabotaging. So we need to like change things up, right? Like, let's get rid of the stuff that we hate, do more of the things that we love. And I don't know, who knows, maybe even turn the whole world into a gig economy. Like, to call me crazy.
Well, those repetitive tasks, and I will say the dangerous tasks in manufacturing were
Absolutely.
replaced by automation. Right? We engineered those out.
Yep.
Because I remember watching the days when Hewlett Packard had individuals hunched over
On the
these circuit boards, soldering parts in, right? And I don't know, maybe the fumes were not harmful to them, but they probably weren't great, right?
yes.
Plus, it's not really life enriching work, right? You're just as like, I'm
100%.
doing this thing and I'm doing this thing, I'm doing this thing. So we engineered that out, right? So integrated circuits eliminated all of that, and then they're getting just dropped into these sockets and stuff. And so people weren't doing the drudgery jobs, right?
Yep.
And so,
I mean, it's actually interesting because that just shifted the work a little bit further down the line, right? So in that whole line, now we have humans, and this is just maybe 2 years ago, we had humans that were then not necessarily assembling the boards, but were definitely the humans looking at the boards to determine which ones were correct and which ones were incorrect. So they were now in the QA role, which is better than the building. Good, we got out of that task. But now we're in the watching, and even that's not a great human thing, right? To have us use our eyes to look at every board and decide whether it's good or bad and flag it accordingly on a system. So enter, of course, artificial intelligence with a specific type of AI called computer vision, that now we could have computer vision. We could have a computer similar to what I said. We'll train it. Here's what a good board looks like. Here's what a bad board looks like. You tell me, bubble up to the ones, remember I mentioned with these models, they'll tell us how confident they are, a confidence number. So it'll say I'm 62% confident, 72. The human now sets a threshold and says, okay, I want to see any board that's not 80% or more, right? So for 80% or more, I'm going to let that go on to the next stage. But if it's 80% or less, there's probably a problem. Only those I want to see. But that means that the 80-20 rule, right? 80% of those boards I never have to even look at because they're just going to go on through because they're good. The 20% that have that problem with them, those are going to come my way. And that, I think, has, like I said, we've now moved that task. So now we're not spending our time even looking at silicon and deciding, or looking at a motherboard and deciding if it's good. Computers will do that, but it still takes us to do that very nuanced, like, what's 99%, what's 100%, what's 80%, especially in things like healthcare and radiology. Like, I don't need to see 1,500 films in a day. I only really can probably really see 100, maybe 15, 20 even. But a computer can tell me which ones I should focus on. And now I can see more patients more accurately with more confidence than ever before. And that's kind of where AI comes in.
Yeah, it was just, so I'm rereading Future Shock. I don't know if you ever read Future Shock.
Oh, it sounds fascinating, though.
So Future Shock was written by Alvin Toffler, and unnamed, his wife, Heidi Toffler, was also a major contributor. The next book they came out with, The Third Wave, she did get her due recognition. So I want to give her that. So think of culture shock, right? So with rapid transportation, right? So I could from here in Texas, I could get on a plane and in a very short period of time be dropped into the middle of Mexico City, right?
Yeah.
A language I'm not very familiar with. I can kind of understand some stuff, but I wouldn't communicate very deep thoughts, right?
Same.
Foods, right? How to buy, I mean, there's just a lot of things, how to drive in traffic, right? There's a lot of things that would hit me suddenly, right? So so we called it culture shock, right? And this was brought about really by the jet age transportation.
Sure. Did you get dropped
So,
into a country or city and you're like, what is
right.
happening?
So in the 60s, in the mid 60s and the late 60s, they did this research and saying that the acceleration of technology was coming at such a pace that we were being that the future was coming faster than we could culturally absorb it, right? So that's future shock, right? and and AI and just this whole I'll say these last two plus
Love this
years,
term. I am a huge fan of this term.
right? This whole with ChatGPT, this generative AI, these LLMs, large language models that are now available, and I'm playing with and doing these different things, um, and just watching the evolution of the rapidity of change. And I said, I need to reread Future Shock, right? Because um, that was 50 years ago when that book was published,
Crazy.
right? And it was a
I'm
culturally, it was culturally challenging for people to understand that. And there, one of the things was just the rapidness of change and the shortening duration of relationships,
Yep.
right? So, people would, his pre-World War II will say, people lived and died in the same community, right?
Yeah.
They born, lived, worked, married,
Yep.
had their families, died, and for generations they did that. And then with different changes in the economy, moving away from the agrarian society, moving into cities, and a lot of things became very transactional. And I thought this is a good time to reread that book and think of it now in terms of what's going on with AI. I should have had that in the carousel as well.
Yeah.
Future Shock is
That's
available right here.
yeah.
It's like 5 million copies sold or some, right? An unreal number. But as you go through the process, and one of the things that you do in your book is, you take these companies, and we talked about the large scale, talked about identifying what is it that you're trying to outcome, what outcome do you want, then find the right model that's going to use it and not give you misinformation, but have the right information. Then there's some other steps, as you start implementing all this stuff and scaling it and deploying it. There's something that is consistent because the teams change at every level.
Right.
And Toffler mentions this in his book, right? There's these, there's the investigation team, and there's the implementation team, and then there's the maintenance team, and then there's the team that's going to sunset that program, right? And sometimes there's the same person that goes through, but generally it's different groups all the way, right? Yeah. The consistent thing that you had in this is ethics.
Yes.
So let's as we're talking about scaling responsible AI from enthusiasm to execution, let's talk about the responsible part of this.
Absolutely. I mean, I always characterize it as a bit of a thread that's woven through everything, right? Rather than, kind of like a raisin or chocolate chip in a muffin, it's more like water in a wave, if you can think about it that way. Okay. It's not like a checklist that you do or a team, just like you mentioned, a team that you assign. It is a way of thinking, a way of building, and certainly a way of scaling. And so that's why I used it in the title of the book, because there is a bit of mischaracterization in the industry that responsible AI is kind of like it's a nice to have, and it's academic. And my experience has shown me that it's very practical, and that practical nature ends up being in a couple of main ways. And these would be maybe relevant to any of you who played around with this GPT system, any of them, any public model. It's important to realize that there is what's called an AI safety system that is used to build it. Now, it's either safe or it isn't, but these components are elements of every model that's deployed. It just depends on how much the team decided. And I do think we are in a different world now where we do have kind of a a evolution of team function and dynamics where it is like at Amazon, Jeff Bezos was a big believer in what he called 2 pizza teams, which meant that you would never have a team that was more than 2 pizzas could feed. So about
Okay. I like it.
8 people. Now, granted, he doesn't have like growing teenage boys like I do, but like as adults, like 2 pizzas, about 8 people. But these teams would be autonomous. And what that meant is that they'd be fully functioning from ideation to execution, everything you would need. So there would be a person who cares about QA, there'd be a person who cares about code development and pipelines, there'd be a person who's ideating, there'd be an engineer, a TPM, a technical program manager, there'd be an executive who can articulate value to the business, right? But it's a fully autonomous team so that you could go fast. You could cycle through what we call sprints, right? In the world of agile, we'd cycle through these sprints of work, and we would be able to do that without having to wait on anybody else because we had everything we needed in our little cocoon. If you look at Amazon.com's website, it is literally a collection of 200 pizza teams. 200 pizza teams. Every little box that you see on the screen is like even the live box is owned by a pizza team. And sometimes they get a little bigger, but in general, they're all releasing new versions of every little piece of the page. That's why the pages themselves never go down. You might see a little section of the page not work right, and you refresh it, and then all of a sudden it works. But the whole page is actually an aggregation of these services. And that's very much what kind of responsible AI is there's a bunch of different capabilities that you have to kind of be thinking simultaneously. So I'll just mention a few of them. Of course, I have tons in my book, but I'll mention a few of them that are the most relevant, I think, when you're starting to understand kind of how to build these systems. So in the safety system, the first thing, and again, maybe it'll surprise you, is human AI experience, that you actually are deliberate in how are the human and AI, how are they going to talk to each other? What are they going to be delegating? What systems are they going to use? What data are they going to exchange? How are you going to protect that data? You want to think through it. Now, there is lots of resources for this. You can actually just go online and search for HAX, H-A-X, for Human AI Experience Toolkit, and you'll get a bunch of different toolkits from different vendors that'll teach you how to do this. But understanding before you build the model, before you've done anything, how is this going to work? How is an AI system and a human going to get along? And so architecting that at first leads you then, when you do finally pick a model to solve your problem, how are you going to tell the model what to do? And that's known as a system prompt, or a very fancy word known today as prompt engineering. But what I'll tell you is if you've ever talked to a model, like meaning you've gone to ChatGPT and typed in some words, I always say like, poof, you've been knighted. You're a prompt engineer. Add it to your LinkedIn resume. Like you're good. Everyone's a prompt engineer, but prompt engineering, it does need to be intentional. How are you going to make sure that I call them the 5 P's of prompt engineering. Like how are you going to make sure that the model knows its job, what role it plays, its audience, what its data set is, right? How does it preserve its information for audit purposes? Like these are classic, like I'm going to tell the model what to do, which means I need to tell it what to do and remember what not to do. And that's a whole collection of instructions. And then the last 2 parts of the AI safety system are things most of us never think about, but are pretty important decisions, which is who owns the model? That's one big piece. And where does that model sit? What infrastructure does it sit on? So that gives us a chance to talk about some of the crazy stuff that's happening in the world today with Meta and Mark Zuckerberg and OpenAI and Sam Altman. They're all doing $500 billion of investment in AI infrastructure across the United States. One is Stargate. The other is this huge innovation on the side of Meta. They're building, one is in Tennessee, the other's in Houston, actually come in your direction. So they're investing in all this infrastructure. And what that means is they're building the hardware that this AI is going to run on. And I think that's interesting because what energy sources are going to be used to fuel that? How expensive is that going to be? And what kind of climate change does that impact, right? Like who's thinking about those questions? Baby Tiger, like who's asking big tiger questions about what a $500 million of AI infrastructure is going to do to our world? It might be good, but are we asking the hard questions right now? That's literally what responsible AI is all about. Being willing to be the one in the room that raises your hand and goes, have we thought about this? Have we thought about this perspective, this condition, this big tiger, scenario? And that really is, responsible AI really is accountable AI. How are you going to hold yourself
Mhm.
accountable for the decisions you make with this technology that can do amazing things, but could also hurt people too?
So that's where we started. We started with the baby tiger, and there's the book right here. Noelle Russell, Scaling Responsible AI from Enthusiasm to Execution. That baby tiger, there's a reason why the tiger eyes are on there. Don't be afraid of it. Learn about it. And uh, Noelle, this has just been a fabulous time. I can't believe the time has
I
flown
know.
by. There's so much, and I didn't even get to talk about uh, Asimov's Harry Seldon,
Oh
eh,
my,
right?
yes.
Right, because
How do you know that about me?
right in the Foundation series, right?
Yes,
Please,
yes.
I should
Oh,
throw those in the. There's so much we should put it more in the carousel,
yeah. But
but
absolutely. I mean, just read, Prelude to Foundation, people. If you read nothing and even have it read to you, it now has an amazing audiobook out on Audible. It is fantastic. I've read it dozens of times across my lifespan. My dad, the first time I read the Foundation series was
yeah,
with my dad and I almost went there when you asked me how I got started, because I was 6 years old when I read that series for the first time, which I would not give that to a 6-year-old now as an
no,
adult. But it was like amazing to me because it immediately got me thinking about this kind of coexistence with machines, but also the impact of pattern recognition. Like literally, it's based on pattern recognition, and human patterns are the worst.
well,
So
that's why I always love economics, because you're trying to lay a mathematic model over a non-mathematical uh, strata, right, with
right,
this people. So let's tell people how to get a hold of you, because there are people, there are businesses, there are organizations who need speakers who are knowledgeable on AI, not just learning a few prompts. Not to you have the depth, you have the long-term experience, you also have the enthusiasm. So how do people get a hold of you?
absolutely. Well, the first thing, I guess the easiest thing is you could just Google me, Noelle, and AI, or you can go to noelle.ai. That's my website. I'll give you access to all my contact information. But for most of you who are professionals, and if you're looking to actually send me a message, another easy way to connect with me is just on LinkedIn. It's I always say my network is your network. So even if, I, of course, am very passionate about advocating for the literacy of everyone in a world of AI. Like the more we all know about this technology, the more powerful we will be to solve our own problems. And I think it could not be a better time to learn this technology, no matter how worried you are about it today.
So find you on LinkedIn.
Yeah, find me on LinkedIn and or noelle.ai. I would love to.
Noel.ai. I love it. And obviously, I'm into to networking, right? Business networking. So
Yeah,
here's the one for the kids. I do have one for the adults. Business networking, a scientific method. But here's the deal. And I say there is no limit to what we can do when we network the supercomputers between our ears. So I encourage everyone to reach out to Noelle today. The easiest way to reach out is to click the book in the carousel, add to cart. One of the things I love about Amazon is you can put in there who you want to send it to. And everybody knows somebody that is dealing with AI. They're working in a business. They live in the C-suite. They're wondering what's going to happen. Buy this book and send it to them. You'll be the hero. It's easy. Add to cart. Noelle, thanks for taking
absolutely.
time. I have just had a blast talking with you, and I have a feeling that we're going to probably do this again sometime.
Yeah, let's do it. I mean, there's like you said, so many places we can go with this. We didn't even get a chance to talk about Asimov, so let's do it.
All
Thanks
right.
for having
All right. So I'm going to sign off, but thanks everybody for joining us today here. Noelle Russell, Scaling Responsible AI from Enthusiasm to Execution. It is in the carousel. Click it, add to cart, be the hero. Have a fabulous time. We will talk to you all next time around.